All right, class. Today, I'm obviously out, so we are going to walk through what today's assignment is. There was an update to Fusion recently, so your system may or may not up boot up a little bit differently. And also, this is the first assignment in Solid Professor that we've got going on. So, I'm going to walk you through what the expectations are for today and make sure you are productive. So, first things first, Solid Professor. So, link is in your Google Classroom. Those of us who were here yesterday on Wednesday, January 21st, created our accounts. So if you were not here yesterday, there were a couple of you in each of my classes. You're going to want to partner with your one of your neighbors to be able to see the assignment, see the document that you need to create your model in Fusion. So, but follow along so that way you know exactly what you need to do to get the assignment done. So this is the website for Solid Professor. We've been watching those videos back in December. We've now got access, Butler Tech, to the academic side of this. So every time you come to Solid Professor, so it's just solidprofessor.com, you're going to click the login button. You are never, ever, ever in this class going to use these login buttons up here. You do that, it does not take you to the academic side. You will not see the assignments. You need to enter in your username and password down here. If you click the Remember Me, sometimes it will just bypass this and automatically log you in. So I highly encourage you to have your Butler Tech laptop remember your username and password, and also have this Remember Me on this device checkbox checked so you can automatically log in. So I'm going to go ahead and log in. Your screen from here will look a little bit different than mine. Again, I'm obviously the teacher, you're the student, so you should come in and you should see the class that you're in. If not, click on Classes up here. It'll take you to the very top of your classes. And then there'll be a bunch of other Butler Tech teacher stuff on the bottom. You don't want to mess with that. You only want to be in your class. So you will find your respective class. So if you're in 5th Bell, it should be McDonald-5th Bell-Design, 2nd Bell, etc. They all are the same. You can see there's 33 assignments in each. It just depends on which bell you're in, which class you're in, so that way I can make sure your grades get uploaded into Infinite Campus and all that kind of good stuff. So since I've got 5th Bell right here, I'm just going to click on that and walk you through what we're doing today. So today we are going to do a design challenge. So you're going to come in here. You're going to left click on Design Challenge. You can click on View Lessons. Anywhere in this box will take you to where you need to go. So left click. From here you will see a bunch of essentially assignments. So we are just going to start with the very first one. It is this big, long, confusing name, 3DMM-CSWA-001. It's called the Stair block assignment. According to Solid Professor, if you're extremely proficient in CAD, it should take you about 10 minutes to make. So again, this is not a super tough part. May take you a little bit longer because this is our first one, but we'll walk through how to do this. So you're going to left click on this. It'll open up a little pop-up, and it's going to tell you, all right, so we are in the assignment, 3D Model Mayhem. Complete this part as efficiently as possible. So at the end, your part should look roughly like this. You can ignore the CSWA prep. That is, CSWA is for SolidWorks. It's another CAD, but all CADs basically function the same. The CSWA is their version of the Fusion User Certificate, which is what you all are working towards by the end of third quarter. So this is a good assignment to just, start demonstrating that you've got the basic skills to sketch, extrude, dimension, etc. That somebody with roughly your amount of hours and practice in Fusion has done. So again, should take about 10 minutes. So the two critical things, and this is very similar to our midterm, units. So you want to make sure you're in inches. This is the way SolidWorks labels it in Fusion. Let me flip over screens. We got Fusion. That's going to be up here when you're in your document settings, you want to just make sure that is in inches and ounce mass. That is Fusion's version of inch, pound, second. So back over to Solid Professor. Come on. Oh, wrong Solid Professor. We'll bring this over. There we go. So, Solid Professor. So, hopefully I've had the right screen up and you've been able to see this. Once I clicked into, we'll bring everything over. Was in here, clicked into this file. This is what popped up. So again, CSWA prep, SolidWorks, but we are doing this in Fusion. They all function the same. Should take you about 10 minutes. That IPS is equal to this inch ounce mass here for Fusion. And then material. So we want to make sure that we're using an aluminum alloy and that our density roughly is that. So I'm going to press get started. That same information that is critical is up here. We've now got our engineering sketches. So this is very similar to what we've been doing on the whiteboard with our arcade parts over the last 3 weeks. You've got a front view. So that is this view here. We've got a top-down view. And it's actually a little bit rotated. I'm not really a fan of the way this is, but if you were to look at this from the top down, that is this. It doesn't have a lot of our visible lines or our hidden lines. So again, not a fan of the way this looks, but again, this is just the top down. If you were looking at this from overhead, your depth is here, got a width here, the width of the whole part from edge to edge is there. And it's actually rotated, so you can see that cutout notch is this front corner here. So from the back corner here to the back corner here is 3.5 inches. This front side's 2.5. So you can start to get your dimensions here. This here is your side view. So overall height is there. Overall height's 2 inches. You've got, a little bit of your cutout notches over here. You can see this kind of does like a little bit of a stair step. So you've got a small square here with this little corner that comes jutting out. That is this right here. That top level is 1/2 inch. From, make sure I'm reading it all right, between the top of this bottom step to this step, so basically the middle step, that's 3/4 inch or 0.75. They did that arrow a little bit backwards in my opinion. Really should have been in between these two lines, kind of like this 2 inches is. So you can see a couple of times they are doing things a little backwards here. So might just be the way SolidWorks does the drawings versus Fusion. So you just kind of got to get used to that. But this is the standard way that we've been teaching and learning that. So I'm going to move this over to the other screen and start working on the Fusion piece. So first thing I'm going to do, I'm going to pause. There's a little bit of a change in the way Fusion boots up. It may or may not have hit your Butler Tech laptop. So we will talk through that real quick. If it has not occurred yet, it will be coming up soon. So when you open up Fusion, they're kind of expanding upon the way and some of the way the buttons look. So for now, you can ignore the bottom 3 here and the what do you want to design pop-up. We don't do anything in this class with electronics design or electronics library, so we won't ever talk about this. We will be doing some drawing work. So all the stuff that we've been sketching for our arcade cabinet, there is a way once you've made your model to create those electronically, look a little bit more professional, like standard blueprints. And that's something we're going to be learning here probably middle to end of February. So more importantly, we now have these three options. So what we've been doing and what Fusion has always defaulted to has been this hybrid design. So when you open up and you start a new file, you could create the part, which is what we've always been doing, is creating parts. When we did the puzzle cube project and we combined puzzle cubes to make a bigger puzzle piece, that was doing some assembly work. The hybrid design allows you kind of to do it all in one place. So this has kind of been our default. For now, we're going to go ahead and we're going to start trying part design. Buttons are still going to work the exact same. They may be in a little bit different order up here. If you don't like it and you want to go back to hybrid design, it's very quick and easy to do that, and I'll show you how. So we're going to start making this Solid Professor design challenge problem. So we're going to start with a part design. I'm just going to click on that. Since my file was in IPS, or inches pounds second, on the assignment, I want to make sure that this says inches. So if I click on this, it's the only one that's inches. At the end of the day, that's the one that's critical for me, is inch. There are two options here. We've got our standard type. We've also got sheet metal. For our class, we don't really do anything with sheet metal, but if you were working in a precision machining shop where you were doing some CAM work, so computer aided manufacturing, or you needed to do some welding or bending or breaking of metal, some of those more industry specific features are in here. Basically the rules for sheet metal. It's also a good thing for like folding cardboard and stuff, but again, everything we'll do in this class is in the standard method. So part design, standard, inch and out mass, and then hit create new. Now we are in a very similar looking screen for us. We've got our workspace, we've got all of our buttons up here. You will notice got a little bit of different options by default up in create. You may or may not have the same. Let's just see, reset all toolbar. Very similar. Create forms kind of popped up here, as well as some automated modeling and some other things. But we still have create sketch at the very beginning. We've got our extrude, we've got our evolve, whole features, so very similar. We've also got all of our modify stuff here. So nothing should be unfamiliar. If for whatever reason you do not like the part design, you want to go back to hybrid, it is a matter of going right down here in your browser. Right below where you can always change the units, there's now a new box that says part design. Like any time before, hit the pencil, get a little pop-up. Want to go back to hybrid, hit convert, and now it's changed a couple of the buttons. That's essentially the difference. There's some difference with the way you can do assembly work, but we'll get into that once we get a little bit more into our arcade cabinet and combining our parts. We'll probably do a little bit one way, we'll convert, we'll see how the other way goes, and then from there, Baller Tech thing, student choice, use the way that works best for you. As long as at the end of the day, your arcade cabinet functions and combines correctly, that's all that really matters. So again, for right now, in your browser, should have units, inches, ounce mass, and then in your design space here, it should be part design. We're going to give this a try. You can see it's unsaved. We can see untitled. So first thing we always do is we save our file. So we're going to change where we're saving this. Since I'm in the middle of fifth bells, I'm going to move over to fifth bell, class files. I'm going to create my new folder. For this, it's a new project, new folder. We're just going to call this design challenges. So you should create a folder that says design challenges. Right now we are not using our mouse. We're clicking, we're typing. So I typed in the name, I hit enter. I've got my folder with that name. I'm going to click enter one more time. So now my location has now changed. I'm in fifth bell. Yours should say students, your name. And then at the very end, making sure you're in the right final folder, design challenges, that folder you just created. does not say design challenges. It is not saving to the right place. It is not right. I will start taking points off for that. We've gone through this enough at this point. Name is not untitled. This is the Stair block, where I'm getting that from. Right here at the very bottom, Stair block. So makes it easy, so that way in a couple of weeks, month, once we've done a couple of these and they're all in the design challenges folder, not trying to figure out, hey, where's the latest and greatest one that you worked on. It's named correctly, Stair block. It's in the design challenge folder. You hit save, ready to go. So now, just like before, nothing has changed. So first step we do, before we sketch, we did have a material requirement here. So it says we are looking for material 1060 aluminum alloy. So let's go ahead, let's change our materials. Let's see what Fusion has available for us. So here in modify, I just dropped that down. Go down to manage materials, or actually, I'm sorry, physical material. Want to change the physical material for this. In our pop-up, I'm gonna make this a little bit bigger so you can see it all. I'm going to type in aluminum. Let's see what we got. Do we have a 1060 in here? Let's just try typing 1060. We've got a steel. We don't want steel. We want aluminum. So we'll go ahead and we'll roll with aluminum in this case. A little bit default. There's not an aluminum alloy or aluminum 1060 that I see. 1060 did not search and find anything. So we'll go ahead and we'll roll with that. We'll hit close. Let's just go ahead and check our properties. For now, I'm just going to sketch a cube so I can see my properties box real quick. Finish sketch, extrude this. You don't need to do this. This is just to give us a good feel for how close we're going to be. So checking the properties on this. Density 1.561 ounces per it's going to be a little bit off, but at the end of the day, I'm going to give you the final answer of what this should look like. So as long as you match mine at the end, it should work. All right. So we're going to click OK here. So I went ahead and I did Google just to convert it and see how close we're going to be. So I did 0.98 pounds per inches cubed, which is what the assignment was asking. Fusion does everything in ounces per inches cubed. 0.1568. And the material we're actually looking for, so should be in 1.568. What we're doing in Fusion is 1.561. So it's going to be a little bit off, but again, end of the day, as long as you match mine, should be good to go. So here in a second, we're going to get to sketching. All right, so we're going to start by sketching this front shape. So if you look at the front, don't worry about the fact that it's got this cutout. So we're just going to create this shape. So step up, arc here. So we're just basically going to use the line tool and get this general shape. I'm going to move this over. I highly recommend maybe pulling Solid Professor up on your Google Chromebook and then having Fusion going on your Butler Tech laptop, so you've got two screens. In the industry and most of the real world, you either have a big screen where you can do things split screen, or you'll have multiple screens. Depending on how crazy you are, you might be like Mr. McDonald and have 4 screens going like I have here at home. So gonna go ahead and just delete everything. So this is my timeline is now blank. I went through and just deleted everything. This is letting me start from scratch. Your best practice, mentioned this before, is always to have as minimum amount of steps in your timeline as possible. So if that's why everything should be in the same sketch that you can do, and just very specific and not just sketching and having a very busy timeline. So we're going to create sketch. I'm going to rotate my view cube to the front. I'm going to select this plane. None of this should be new. So I'm moved over, or I panned the workspace to get the origin down in the corner. I'm going to use that as kind of my starting corner. I'm going to go into the line tool, left click on the line tool, start down here, left click over here on my origin. It goes up a little ways. It's about a ½ inch. Comes over a little ways. At this point, I've got an arc, so I'm going to kind of give myself a little curve. It's more sharp like that. Then it goes straight vertical for a ways. It goes over for a ways. Straight down, straight over, straight down, over, and then straight to the bottom, and then to close it all off. So general shape, I know dimensions are not right, but you can see if I put them side by side, this general shape kind of equals that. So it took me about 15-30 seconds to make that shape. That's what you're looking for from a time standpoint to get this done as quickly as possible. So next step, we're going to start dimensioning everything. So I'm going to click the dimension tool. If yours is not here like mine is, always hit the create, get your drop down. Sketch dimension is at the bottom. You can also press D, that is your keyboard shortcut. So you should be very familiar with dimensions. If you're not, start getting used to it. We're going to be doing that a lot here going forward. So I'm going to start over here from the left and work my way around. If you look at that picture from the bottom to the top of this line, I'm left clicking, so I left clicked on the bottom, left clicked on the top, dragging this over to the side so I can see it. That is 0.5. It all auto shaped. In my picture, I've got this R 0.50 pointing to here. That is the radius of this arc. So going to click on the arc. Going to come over to here, drop it down, 0.5. Between here and here, 0.5. Between here and here, 0.75. Between here and here, 0.75. Starting to get that shape, so just to bring it over, 0.5, 0.5, radius of 0.5, radius of 0.5. Then our steps down, we got a ½ inch thickness here, 3/4 of an inch thickness here between this line and this line. Between these two lines, 0.75. You'll notice it does not bother us with the overall. At this point, we'll pick that up from over here. But again, at this point, we're kind of good with this front angle. This is all depth information. We do have a height here. So the overall height from the bottom to the very top, you can see that right here, is 2 inches. So I'm going to scoot this over. Dimension, so left click on the bottom, left click on the very top, move this out to the side, 2 inches. I'm going to undo that since it went a little wonky on me. There we go. We'll actually start from the smallest of the steps. So it tells us our small step, or this little corner here, which is this piece, is only 1/2 inch tall. Then from this line to this line is 0.75. That is this one. And then the overall is 2. So if I do it from the smallest to the top, it won't go crazy looking on me. So bottom to here, that is 0.5. Bottom to here. Oh, nope, that's not where it dimensioned from. Dimension from here to here. That one is 0.75. And then from the very top to the very bottom, we've already got that. That's over here. That is 2. So now we're starting to get the shape locked in a little bit better. So now if we look at our sketches, all the dimensions we've got, kind of bring it out to the side. We've got all of our dimensions from the front, all of our dimensions from the side. Now we just need to figure out how to incorporate these. So the overall part width, the widest it goes, is 3.5 inches. So that is going to be the length, the dimension of this bottom line. So we've got this to this, 3.5. And then I'm going to change my view environment. I think we normally go with photo booth. That arc is still a little bit. But we're relatively pretty good. We'll leave that for now. We're going to go ahead and extrude, do everything else that we need to do, and then we'll come back and make sure that this all gets locked into place. So we're going to finish this sketch. You'll notice I'm not fully constrained or fully dimensioned. My arc is not. It basically isn't really sure where the start and end points are. So we'll come back to that, make sure that it's good at the end. But we're going to go ahead and we're going to extrude this. It auto-selected Mr. McDonald. Distance. So if we look at the drawing, this one takes a little bit of math. So just to walk you through this. So from the top-down view, if we just imagine that this portion is not cut out yet, we can see a 1/2 inch here and then a radius of 1 inch. So the radius from the center of this circle that is cut straight down, 1 inch, and then a 1/2. So our overall extrude depth is 1.5. We're just adding those two parts together. So our distance, 1.5. Now if we ISO this and compare it to our picture, we're starting to look pretty good. I mean, that has not taken us a lot of time. Probably took me more time to talk and explain things as I was going than anything else. But now all we're missing is this circular cut. So if I spin this to the top view, looking straight down, I need to throw a circle and do an extrude cut from the top down. So I'm going to sketch, and I can actually do this from the bottom up. So I'm just going to click on, I'm going to hide the body so we can just see our plane. I'm going to click on that plane, bring it back, bring my body back. I'm going to do a center diameter circle. If I look at my sketch, the center of the circle is the corner. but also remember that that is this front corner, so it's a little bit confusing with the orientation of this picture. I'm going to start my center point circle right here on this corner. Before I do that, just to make sure I'm using it, I'm going to project and include that corner. Click OK. And then center point circle from that. I'm going to go out. Before I left click my second time for my circle, notice it's saying specify the diameter of the circle. My measurement on my picture is in radius, so radiuses are half of a diameter. So I want this to be a 2-inch circle. So diameter of 2, hit enter. That's how big my circle should be. It's perfectly on my corner there, so I can finish my sketch. I can extrude. The circle's already picked. I want to do a cut. It goes all the way through the object. If we look, it doesn't stop halfway or part of the way. So instead of taking the time to go, okay, yeah, it goes up 0.5 plus 0.75, that's 1.25 inches. I'm just going to change my distance to all. Make sure OK is working. Click the button. Now when I ISO it, I'm going to change my display settings a little bit more. I just want to go shaded. With visible edges only. There you go. So there's our overall object. Here we go. All of our measurements are good. One thing we can do just to make this locked in a little bit better, if we go back into our original sketch, let's tangent this to here, and now we're constrained. So basically we just said, hey, this arc needs to be a smoother line. Make sure it's not a rough edge. It's tangent with it. So that fully constrained it. It didn't move that arc too much, so it left us in place. So at the end of the day, we're good with our overall model. We hit properties. At this point, our overall mass, 6.55. Let's see if Solid Professor would not take that, but again, remember our density is a little bit off. So if you come up with 6.55 ounce mass, for me, I am good with that. I'm going to pause this. I'm going to do the conversion over in Google and see if Solid Professor takes this as accurate. 1 second. So to actually show you that what we did is good, and it would actually take this, but because we're in different units of measure, Solid Professor is going to tell you that you're wrong. Mass infusion, 6.55 ounce mass. If you go to Google, wrong Google, and since I still had my original conversion up, mass volume, 6.55 ounces per cubic inch equals 0.409. Solid Professor is looking for this in 2 digits, so that's 0.41. If I type in 0.41, hit check mass, it now tells me congrats, I've got the right answer. So that's how you can double check if you wanted to do all that kind of conversion over to check yourself in Solid Professor and see that you are correct. But the end of the day, follow my instructions and you will get the right answer. 6.55 ounce mass is what I'm looking for to submit this assignment and say that you are done. Turn this over to isometric. Get your properties window up. Just put it side by side, kind of like this. Snipping tool. Get me this. Submit it and upload this picture into Google Classroom. Back out. Hit save. Make sure you get to version 2. So I will, once you save, upload the picture, you are good to go. I will know, one, since you submitted in Google Classroom, that you have done it. It will make me go to Fusion and check your student file. So do not upload your partner's picture. I'm fully aware that's an easy way to get this done. But if it's not under your name, or if your start and your finish from version 0 to version 1 to version 2 are 20 seconds apiece, I also know you did not do this. So please do it. Learn the skills. Get 100%. If you got any questions, I'm not here today. Ask your neighbor. Get it done. Submit something so I can give you full credit, or at least give you credit for doing it versus waiting until I get back. You know which students you are who like to say, Mr. McDonald, you weren't here. I couldn't do it. Give it your best shot. I've got faith in you. Y'all have done a great job. So keep it up. This video is only 36 minutes. I rambled a little bit. You got 50-minute class, so hopefully you've been working along, getting it done, and you've got 10 plus minutes to do whatever. So have a good day, and I will see you tomorrow.